Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with the design of reinforced concrete elements in the topic of doubly reinforced beam. So the problem is design a reinforced concrete beam supported on two walls that is 500 mm thickness spaced at the clear distance of 6 meter. So the beam carries a load of 30 kN per meter. So the size of beam is restricted to 300 mm into 500 mm. Use M20 and Fe415 steel. Okay, so now the given values. So width of support is 500 mm. So then clear distance. So clear distance is 6 meter. Okay, so then WL is 30 kilonewton per meter. So the load is given. So then B small b is 300 mm and depth is 500 mm. Okay, so then FCK is 20 Newton per mm square. So then Fy is 415 Newton per mm square. Okay, so these are all the given values. So first thing is step 1. So first thing we have to find out the effective length. So for effective length L, so we refer page number 35 in IS 456. Okay, so now we got the clear span plus effective depth. So clear span plus effective depth is 6 meter plus 0.47. So now we can assume the cover is 30 mm. Is 30 mm. So now small d equal to capital D minus small d dash. Okay, so the cover is d dash. So now we got the value of 500 minus 30. So now d is 470. Okay, so that's why we are putting 0.47. okay, so now the clear span plus cross section distance between the supports. So clear span plus distance between the center to center distance between the supports. So now 6 meter plus 0.25 plus 0.25. okay, so the support is 500 mm. So in the half the distance, so is the center to center, so we can take 0.25 and 0.25. so we got the value of 6.5 meter. Okay, so here we got the value of 6.47 meter. Okay, so now comparing to 1 and 2, so this is 1 and this one is 2. So whichever is less we have to find out, we have to take whichever is less. So from the 1 and 2 we got the value of effective span L equal to 6.47 meter. Okay, so this is a less value, so we take a span as 6.47 meter. So next step we have to find out the ultimate moment. So step 2, find ultimate moment. So for the ultimate moment we have to find out the self weight. So WD equal to B into D into gamma. Okay, so now we got B is 0.3 and D is 0.5 into unit weight of concrete is 25. Okay, so now WD equal to 3.75 kilonewton per meter. Okay, so WD we found out. So that is dead load. So next thing is live load. So WL live load is given is 30 kilonewton per meter. Okay, so now we got the value of total load equal to WL plus WD. So now WL is 30 plus WD is 3.75. So totally we have 33.75 kilonewton per meter. Okay, so from that we can find out the ultimate load. So ultimate load WU equal to W into 1.5, that is factor of safety. So now we got 33.75 into 1.5. Okay, so ultimate load WU equal to we got 50.625 kilonewton per meter. So this is the ultimate load. Okay, so from that ultimate load we find out the moment, ultimate moment, so that is mu equal to W L square by 8. Okay, we can substitute W is 50.625 into L is 6.47 square, that is we found out 6.47 divided by 8. So from that we got the value of 265 kilonewton meter. Okay, so this is the moment of this section. So next thing is from IS 456 page number 96 in IS 456. So we can calculate the limiting limiting moment, so that is mu limit. Okay, so now the formula is mu limit equal to 0.36 into xu max, that is neutral axis, into d. So depth of neutral axis 1 minus 0.42 into xu max divided by d into b d square into fck. Okay, so this is a formula, so we can substitute all the values over here. So now for Fe415 xu max divided by d equal to 0.48. so this is from page number 17 IS 456. Okay, so now we can substitute all the values over here. So mu limit equal to 0.36 into 0.48, so that is xu max divided by d is 0.48 into 1 minus 0.42 into 0.48 into, so b value is 300 into d value is 470 square into fck is 20. Okay, so the only unknown is mu limit. So now solving this we got the value of mu limit equal to 182.85 kilonewton meter. Okay, so now the mu is 265. Okay, so mu limit is less than the 265, so that is mu, so we can provide the doubly reinforced beam. Okay, so because the mu limit is only 182 but our moment is 265. Okay, so it's beyond the limiting value, so we provide the doubly reinforced beam. Okay, next thing is third step, we have to find out the compression steel area. So step 3, so compression steel area we have to find out. So now d dash by d equal to, so 30, d dash is cover is d30, so in the depth is 470 equal to, so we got the value of 0.036. Okay, so now FSE value, so FSE value in SP16, so SP16 codebook we have to find out. So from that page number 13 table F, so we got the, so table F, so 0.05, so the value will be 355, and for 0.1 the value will be 353. Okay, so here we have 0.063, so in between value we can take. Okay, so now interpolation, so for the interpolation FSC equal to, so interpolation is less value, so 355 minus 355 minus 353 divided by 0.1 minus 0.05 into 0.063 minus corresponding 0.05. Okay, so now FSC value is 354.48 Newton per mm square. Okay, so now we can take page number 96 in IS 456. So ASC equal to mu minus mu limit divided by FSC into d minus d dash. Okay, so now we can substitute all the values over here. So now we can take 265 into 10 power 6, that is in kilonewton meter, so we can convert into Newton mm. So minus mu limit is 182.85 into 10 power 6 divided by, so 354.48 into, so that is FSC value, into 470 minus 30. So solving this we got the value of 526.7 mm square. Okay, so now we can take 16 mm dia bars. So now we have to find out the spacing. So now first thing is number of bars. So number of bars, capital AAC divided by small AAC. So we can take capital AAC is 5, 26.7 divided by small AAC area of 1 bar, pi by 4 into d square, that is 16 square. Okay, solving this we got the value of 2.62. So now we can provide 3 number of 16 mm dia bars. Okay, so this is as a compression reinforcement. So next thing is we have to find out the tension reinforcement. So now we have to find out the area of tension steel. So that is in IS 456 page number 96, we can take AST equal to AST1 plus AST2. So now AST1, so the formula will be 0.5 FCK divided by Fy value into 1 minus root of 1 minus 4.6 mu limit divided by FCK B d square into B into D. Okay, so now we can take substitute all the values over here. AST1 equal to 0.5 into FCK value is 20 divided by Fy value is 415 into 1 minus 4.6 into 182.85 into 10 power 6. So that is mu limit value divided by FCK is again 20, B is 300 into D is 470 square. Okay, into B into D, that is 300 into 470. Okay, solving this we got the value of AST1 equal to 1343.82 mm square. Okay, so second thing is AST2. AST2 formula is ASC into FSC divided by 0.87 Fy. Okay, so now we can substitute all the values over here. So 520 ASC value is 526.7 into 350, FSC value 354.48 divided by 0.87 into Fy value is 415. Okay, solving this we got the value of AST2 is equal to 517.11 mm square. So now AST equal to AST1 plus AST2. So now AST1 is 1343.82, then AST2 is 517.11. So now we got the value of AST equal to 1861 mm square. Okay, so now the tension steel reinforcement area is we found out. So now we can use 22 mm dia bars. Okay, so now we can find out the number of bars. So number of bars is capital AST divided by small AST. So that is the capital AST is 1861 mm square. So divided by, so the small AST pi by 4 into d square, that is 22 square. So now we got the value of 4.89 bars. So now we can provide 5 numbers of 22 mm dia bars. Okay, so this is the tension reinforcement. So next thing is we have to find out the check for shear. Vu equal to Wu L by 2. So now ultimate moment is 50.625 into L value is 6.47 divided by 2. So now we got the value of 163.77 kilonewton. So now the from IS 456 page number 72 is tau V equal to Vu by BD. Okay, so now 163.77 into 10 power 3, so we can convert into Newton. So B is 300 into 470. So now we got the value of 1.16 Newton per mm square. So this is the tau V value. So now we can percentage of tension reinforcement. So now the capital AST divided by BD into 100. So now we got the value of 1861 divided by B value is 300 into 470 into 100. So now we got the value of 1.32 percentage. Okay, so now we can take table 19 in IS 456 page number 73. So the calculate the shear strength of the concrete. So now for 1.25, so we got the value of 0.67. So now 1.5 we got the value of 0.72. From that interpolation we got tau c equal to 0.684 Newton per mm square. So this is a tau c value, and that is known as tau v value. So now tau v is greater than of tau c, so shear design is required. VUC equal to tau c into BD. So now 0.684 into B is 300 into 470. So now VUC equal to 96.4 kilonewton. So now shear carried by the stirrups. So VUS equal to VU minus VUC. So VU value is 163.77 minus 96.4. So now VUS equal to 67.37 kilonewton. So for that VUS we can provide the shear reinforcement, that is stirrups. So let us provide 10 mm dia bars. Okay, so now ASV equal to 2 into pi by 4 into 10 square, so that is 157 mm square. Okay, so from page number 73, VUS equal to 0.87 FY ASV into D divided by SV. So now SV equal to 0.87 Fy ASV into D divided by VUS. Okay, so now we can substitute all the values over here. So SV equal to 0.87 into Fy value is 415 into 157 into 470. Okay, so D value is 470 divided by VUS equal to 67.37 into 10 power 3. Okay, so now SV value is 395 mm. Okay, so this is first one. So second one is from 47, page number 47, 0.75 into D. So now 0.75 into 470. So now we got the value of 352 mm. Okay, so next thing is, third thing is 300 mm. Okay, so now we can provide 10 mm dia bars at 300 mm center to center. Okay, so whichever is less we have to take from those three things. So 395 and 352 and 300. So whichever is less we can take. So now we can take the 300 mm. Okay, so now we can see the cross section. So the total depth is 500 mm. So then with this 300 mm, so these are all given values. So now we can provide so 5 numbers. So 5 numbers of 20 mm dia bars. So 3 number of 16 mm dia bars. Okay, so this is the compression reinforcement, this is tension reinforcement. So this is a method we can solve the problem. Again we will see next video. Thank you.